Thanks for joining me. I really appreciate. My name is Bharav Patel. I'm a specialist essay. I work with Amazon and really excited to talk about building observability solutions. First of all, I want to understand how many of you are familiar, from the SRE or developer background. All right. Okay. So anyone never had a production outage in your system? Anyone? That's fine. All right. So yeah, you have seen this line many times today. Everything fails all the time. And the question is not the things will fail or not, but when it fails, how resilient you make it. And how do you measure a success of your observability solutions? Mainly by measuring two parameters, mean time to detect and mean time to repair. For observability solutions, we'll be mainly focusing on detection because we have seen that when you have successfully located the issue, it doesn't take much time to repair. And minimizing both will minimize the impact of your application. Thanks to microservices or cloud-based applications, you can build scalable and complex applications. But at the same time, it will increase the complexity of your application. So if something fails in your thousands of your microservices, it is very hard to find where the issue lies. And the more time you take it to locate the issue, you will have chaos, loss of revenue, loss of trust. As per one survey, we might have generated 149 zettabytes of data. But the challenge is not storing the data. Challenge is challenge is how to get the value out of this. And this is all machine generated data coming from your applications, servers, database, or IoT devices. And that tells a lot about your applications. Is my application working fine? Was there any security breach in my system? Or which features are used most in my application? So what is observability? The theory says it's finding the internal state of your application by using three main pillars: logs, metrics, and traces. Logs, most of you might be familiar. Metrics, it's a quantitative measure which tells the health about your application server. So it could be your CPU usage, number of processes, latency of your application. And traces. We have seen that most of the people are familiar with logs, metrics, they have this implementation, but less people has this trace analytics in place. So what is trace? Trace is a sequence of processes when it propagates to different processes. Let's say you are building an e-commerce application, and to make complete transactions, you start with the check login, then you go to catalog search, then you do checkout, and then payment. So as you progress through this, your trace ID becomes the parent ID, which helps us to correlate end-to-end systems. And then we have different sub-processes, which we can identify using spans. So trace a parent process ID, and then span ID, which is consisting of respective sub-processes. All right, so observability is mainly built using two components. One is client, where we use to capture instrument your application, and one is a backend where we store the data, store the observability data, and do all those analytics. We'll be talking about OpenSearch for the observability backend. Anyone here familiar with OpenSearch or Elasticsearch? Wow, great. Most of you. Perfect. All right. So OpenSearch it's a community-driven search and analytics suite which is built on Apache Lucene library. And it comes with multiple plugins, including observability, alerting, anomaly detection, KNN, and many more. And you don't pay any fees for using any of the plugins. It's completely free to use. And it is, if you are tracking the news, Amazon has donated the code base of OpenSearch to Linux Foundation. That means we are fully committed to open source. And it is, there are many organizations who is contributing to this project, like Uber, SAP, and many more. OpenSearch has mainly three use cases. Search, you can do a fast full text search, fuzzy search, personalization, ranking, boosting, all those things. Analytics, where you can send your logs, metrics, traces to OpenSearch and perform a real-time analytics, observability, security analytics. And last one is vector and GenAI. So For those who don't know, OpenSearch is also a powerful vector database where you can store billions of vectors having multiple dimensions and build powerful GenAI applications. But the scope of this session would be only analytics because we are talking about observability. All right. OpenSearch, as I told you, OpenSearch is a fully open source. You can run it anywhere, any cloud providers. Amazon offers this as a managed service, and it comes with two deployment options: provision one and serverless. Provision, you size your cluster accordingly depending on your data. So let's say you have 5 terabytes of data, you will size your cluster and deploy the resources accordingly. Second deployment option is serverless. As the name suggests, you keep using the service and it will adjust the underlying resources based on the usage. And every service deployment comes with the OpenSearch dashboard. That's a user interface component of working with trace, logs, and using the plugins. All right. So just last word on the interaction model. Interaction model with OpenSearch is very simple. It uses REST API. So to send the data from your applications, you invoke the REST API to store the data. And once the data is stored, all fields are searchable, unlike databases. So you can search across all the fields. To consume the data, you can use dashboards or you can use a programmatic access using REST APIs. All right, and then finally, OpenSearch, we have scaled the support up to 25 petabytes because when you're working with observability, you are generating a lot more data, and it's better if we have data for all your applications in a single cluster, so you don't have to break the clusters and do operational overhead of managing multiple clusters. All right, so we talk about OpenSearch as a backend that will store our observability data. Now let's come back again to the client side, which is the instrumentation part. So if your application is running, how we are going to capture those important signals? And that process is called instrumentation. Let's say your application is running on Kubernetes or SaaS, you have a SaaS application, or it's running on any cloud. And to capture those metrics, we need to have some kind of agents that will capture those important signals from that. So we need to either run it along with your application or run it as a sidecar. And we have different options. A couple of them are coming from proprietary solutions. A couple of them are coming from cloud native. I'll be talking about OpenTelemetry. Anyone not familiar with OpenTelemetry? All right, so OpenTelemetry is a popular approach for instrumenting your application. It's a client, so it just used to capture the data, process the data, and export the data to backends like OpenSearch. And if you want to change your backend, you can use without touching your clients. Yeah, it's a single vendor agnostic, we can say, set of APIs, tools. And what you can do is that you can instrument your application in two ways. One is without a code or no code solution, where you can use the libraries provided by OpenTelemetry and just include them in your application. And that will hook your application, get those edge data from your application. So that's a no code. But if you want to capture something custom, you can write a piece of code, put them in your application, and that will capture the code. Again, there are multiple options for different programming languages. It also gives you that semantic naming convention. So you have your on-premise application and you have your SaaS application. That gives this standard naming convention so that process ID, name of the process ID remains same across different environments. All right. So with that, we have OpenTelemetry agents, which is running with your application and that exports the data, Amazon OpenSearch ingestion service. It is an ETL tool which has a capability to get the data from different sources, transform that, give it a structure which you can understand, and store it into OpenSearch. So your logs and trace data goes to OpenSearch. But for metrics, we recommend something purpose-built, like Prometheus. And Grafana you'll be using for exploring the metrics, generating alerts. And with that, you have your logs, trace data into OpenSearch. You'll be exploring this data into OpenSearch dashboard, and your metrics data goes to Prometheus, and you can explore it in Grafana. But you can get real beauty comes when you have all these three main signals in a single platform, right? And that's why OpenSearch dashboard has a capability to get the data from Prometheus in real time, so that you now have logs, traces, and metrics in a single dashboard. And that gives you that capability to correlate between your logs, metrics, and traces to locate the issue. All right, so now we have instrumented these observability signals, but how can we use them? One way is using OpenSearch dashboard. I told you it's a user interface component which comes with every deployment of the service. And so you can visualize your data into this graph form. It comes with pre-built dashboards, so you can do all your data exploration, create plugins, use that data to understand the trend. But you cannot keep looking at the dashboard for a production application, right? That's why we have different plugins for alerts, where you can write a rule that will keep looking at the real-time data, and if that rule is satisfied, then it will generate an alert or send it to, let's say, your SRE Slack channel. But again, alerting plugin has also a limitation because it only works with the known patterns, right? But that will not the case with the production application. You will always be learning a new patterns in your data. That's why we have an anomaly detection. This is a ML powered tool. It looks at your historic data, it looks at the range, and when there is something found which is outlier, it generates an alert. It gives you two data points. I think this is blurred, but what it gives you is anomaly grade, which tells you how deviated is this data point from the normal range. And second is the confidence score. How confident the engine is that this is being the anomalous data. With that, you can either suppress your false alarms, or let's say I want to only generate alerts when confidence score is more than 0.5. So that, because we have seen that most of the time people struggle with these false alarms, and that gives you the capability to additional knobs and tunes to adjust the behavior. Yeah, anomaly detection, yeah, working well with the dynamic patterns or new patterns. Finally, talking about trace analytics. When working with the microservices, there are many moving parts. It is important to understand how your services are interconnected to each other. And you can do this with service maps. So if you look at the first diagram on the left, OpenSearch generates these service maps out of the box. And okay, this is how my microservices are connected with each other. It also gives you, I don't know if you are able to see that, but it also gives you a nice view with different data points. For example, first is the error. The application with the highest error will be grayed out or with the high color intensity. Second is the latency. Which application is taking most of the time? So you can easily isolate that process. And last one is the throughput. You can also see which application is used most or getting most of the traffic. So that's service maps, which can speed up your investigation if there is any error. Second is a trace group. You can it groups the traces for, let's say, checkout page or login page or payment page, and you can see that over a period of time, let's say over 24 hours, what is the range of my trace group, are there any errors, all those things. And last one is a trace and span details. If you remember, I was talking about the trace, which is like a parent ID, and then there are multiple spans for different processes. So for each trace, you can see this a breakup, and you can see this. To complete my end-to-end e-commerce transactions, I'm spending, let's say, 500 milliseconds just on the database call. There's something wrong with this integration. If there is error, that will pop up here against the microservices. So the process is, look at the service maps. You can see the errors. You can isolate the process having the highest error rate. You now go to this trace and span details. You again isolate, okay, this is the error. And the beauty of this trace span details is that you have this correlated log entry, which you can again switch back between trace and logs to get to that root of the issue, which I'll show you in the demo. Another thing is about the logs, because logs gives us the clarity what's happening with my application. So once, let's say, I have found the trace having an error, I know trace ID and I can filter out the right logs. But let's say if you want to do this log exploration, ML powered log analytics gives you that additional features. What it does is it groups, if you have, let's say, 1 million log lines, it groups the similar log lines into one. So you are only left with maybe 10 or 20 different log patterns. And it is very easy to find that specific log error from 20 records than a million records. So it gives you that, it speeds up your investigation. Second thing is that you can do this log surrounding. You can see what are the surrounding events in your application, or log tailing, what happened right after that event. Second feature which OpenSearch gives you is AI assistant. So anyone who is working on any of the observability solution or analytics solution, you have to write a code. OpenSearch gives you that DQL or PPL language to find a data. Let's say, what is the error for last 7 days? So you have to first prepare a query. But with this AI assistant tool, which is ML powered tool, you can simply ask a question in a natural language. Show me all the errors for last 7 days. And you don't need to specify even a field name. This tool is smart enough that will look at your schema, that will look at your data, and will find the appropriate fields to look for the error, appropriate fields to look for the time range, and gives you the data. So now if you see here, if I say, show me all the log where extension equals dab, and it will talk to ML model, it will generate the query for you and gives you that results. It can also generate the visualization for you. So anyone who is new to the platform or is not very familiar with the query language, they can also use this for exploration. All right, so now I'll go to the demo and show you how you can use this trace analytics to speed up the investigation of the issue. All right, so this is a microservice based process. So we have different microservices, inventory, recommendation database, and it is hosted on EKS. All right, so it's going too fast, but yeah. So what I'm doing is that I'm collecting my logs using the FluentBit. I'll bring it here. So yeah, and FluentBit will collect all my logs, and it is also deployed as the sidecar. Second is a trace data or the matrix data that will be collected with the OpenTelemetry, and will send that to OpenSearch ingestion service. OpenSearch ingestion service that will send logs to OpenSearch and matrix data to Prometheus. Now what I'll do is that I'll use this sample application to generate data, right? So this is, I'm doing some fake transactions that will generate the data in OpenSearch. And now I'm going to OpenSearch dashboard. This is a user interface I was talking about. This is a look and feel of the dashboard. We have different plugins. I'll be talking about observability. Okay. So now I have this OpenSearch ingestion service, which has saved my log lines into a sample app index. Index is nothing but you have tables in database, so it's called index. And to create an application, is it visible or is it coming? Yeah. So as soon as select the index, I am presented with the different options. So I'll pause it here. All right. So I have now all these microservices when I selected the right index. And once I have selected these microservices, it will generate these service maps. And now I can see, okay, this is how my applications are interconnected, which I can see it with the error or latency or throughput, and easily identify where is this. Yeah, conscious of time, I'll forward this demo bit. I'll skip the metrics part. All right. So I have purposefully failed application for the payment, and that will show as 100%. What I'll do is that I'm doing this trace analytics, I'll take the application having error rate. I see that I have 11 traces with the failure. So I'll select one of the trace. So these are all the trace with the error. I'll select one of the trace. I'll look at the breakup here. And if you see here, I have the error which is coming from payment application. Now I want to move back to the log. What is that relevant log line? I want to see more about why this is failing. So I'll go to log analytics and filter by the trace ID. And now I can get to the root of the issue. This is because I'm getting that 503 error on the service. So yeah, initially what we did was that we failed the application. We picked the right traces with the errors, and then we went to the log analytics with that trace ID to get to the root cause. So I'll forward this. I'll leave this demo here, and just to emphasize on observability requirement, which is much more than a monitoring solution, because monitoring works with your known patterns, and the key difference is that monitoring system can answer, is my application working fine or not, in yes or no, but observability systems can help you find why my application is not working. So it's essential to keep your application uptime, and OpenSearch is a open source tool to build your observability applications. So from with that chaos to fun for the developers and SRE. And with that, I'll wrap my presentation. These are publicly available GitHub and repositories for the observability solutions. Thank you very much. Yeah, I think we have some time, but if you have any questions, yeah. 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 So yeah, you can plug CloudWatch to OpenSearch. There are options. So now we have recently launched a zero ETL integration between CloudWatch to OpenSearch. So you don't have to write any complex pipelines to bring your CloudWatch data into OpenSearch. Now, what additional you get by OpenSearch? So as you know that CloudWatch is a solution for keeping your data in a short period. But let's say if you want to store your data for larger duration and want to enable a complex full text search, I talked about it is built on Lucene library, which is a powerful text search. So if you want to do a fuzzy search, personalized search, you have that substring from that search. So let's say you have a UUID, right, coming from your application log. You want to find a half of that UUID. All those things can be done pretty efficiently with OpenSearch. Yep. No. Yeah. It is completely open source. You can deploy it in AWS. AWS manage it, offers this as a managed service, but you can run it on your self premises, GCP, Azure, anywhere. So first of all, we have many proprietary solutions, like I don't know to name this, but let's say Elastic, Splunk, or any other things like which supports this thing. Main distinction is this is community driven, no license cost, because most of the vendors out there cost you for using the observability plugin. There is no cost for that, and you can use the, let's say, visualizations, all those things which is developed by the community. Yeah. Any other question? All right. Yeah. Okay, so you have X-ray for storing metrics and traces, right? And for logs, CloudWatch. Okay, yeah. So when you want to do a correlation, it is better to have all those things in a single place, and that's why we recommend that you build that integration to bring that data into OpenSearch, so you have everything in a single place. And yeah, of course, from the vendor lock-ins, there is no vendor lock-ins, because let's say you are running on AWS and you say that, okay, this is we are not happy with the charges Amazon is charging, we want to move away. then you can simply go to self-premise or Azure without changing any of the code, just that you have to deploy or manage on your own. Just conscious of time, I don't want to delay the next session, but yeah, I'm here if you have any other questions.